Hello. So, we are going to do 1H today, evaluating and graphing piecewise functions. We just finished 1G, piecewise functions. And the only difference between these two worksheets is that 1G is linear only. So you'll notice all of the equations in this whole worksheet are all lines. They're all linear. In 1H, we're going to up the ante a little bit, and we're going to include nonlinear equations. So that includes exponential equations and quadratic equations. So evaluating piecewise functions here is the exact same as we did in 1G. You're going to find the equation that you're going to use. You're going to choose the equation based on the section of the domain that it is in, and you're going to evaluate it with that equation. So, for example, f of negative 2, I'm going to use the f of x equations for both 1 and 2. And I have to choose one of these two equations based on where negative 2 exists. So, is negative 2 less than 0, or is it greater than 0? Of course, negative 2 is less than 0. So we are going to use this first equation for it. Negative 2 exists in that section, less than 0. That one. So f of negative 2 is going to use this 2 minus x squared. So it's going to be 2 minus negative 2 squared. And from here we're going to use our order of operations. Groups followed by exponents, followed by multiplication, division, followed by addition, subtraction. We're going to do our exponent first. So negative 2 times negative 2 is 4, and 2 minus 4 is negative 2. Okay. On the other hand, let me grab a different color. F of 7, well, does 7 exist in this first section or this second section? Of course, 7 exists in this section. X is greater than 0. Negative 2 was part of this one. 7 is part of this one. So we're going to use this second equation, which is negative 5x. So negative 5 times x, but x, of course, is 7. So our answer is negative 35. Numbers 3, 4, and 5 use g of x. So you have to choose between these two numbers. 3, 4, and 5 are g of x. Numbers 6, 7, and 8 are h of x, and you have 3 to choose between. And the answers will be in this binder to check your work when you're done. Let's move on to graphing. So graphing piecewise functions, you're going to have to do some graphing of exponentials and linears and quadratics. And you're going to have to determine the section of the graph that it exists in. So the way I did this on the last worksheet was I would graph the entire line beginning to end and then erase the section that didn't apply. So I will do that again for this first equation, 2x plus 1. So the line y equals 2x plus 1 has a y-intercept at 1 and a slope of 2. So the line looks like this. We count up 2 and to the right 1 to find the next point, and there's our line. However, we know that x must be less than or equal to 0. So I'm only going to be keeping the section of the line that's to the left of the y-axis. I need a solid dot because of this or equal to bar, and I'm only keeping the left-hand side. So I'm going to erase everything on the right. All right, let's call this one the green one. So we've got a solid point there, and it's going to go off to the left that direction. So there's the first equation. The next equation I'm going to do in orange here, so you can see it separately, is a quadratic. And I think the easiest way to graph quadratics when they are piecewise functions is to create a table. So I'm going to create a table, and I'm going to plug in various x values. But because I know what part of the domain I'm looking at, I'm only going to plug in x values in this section of the domain. So I'm going to include 0, not because I'm going to have a solid point there, but because I'm going to have an open point there, right? This line does not include x equals 0 because the first one did, right? But I'm going to have an open point at x equals 0 somewhere, and I want to know where that goes. And then x must be greater than 0 for this quadratic, so I'm going to go up 1, 2, 3. I might even go further. Let's find out. So let's plug in 0 first. So I'm going to do 0 squared minus 6 times 0 plus 7. This is going to be 0 minus 0 plus 7, so I've got a point at 0, 7, or an open circle, as it were. If I plug in 1, that's going to be 1 squared minus 6 times 1 plus 7. That's going to be 1 minus 6 plus 7 is 2. If I plug in 2 squared minus 6 times 2 plus 7, that's going to be 4 minus 12 is negative 8. Negative 8 plus 7 is negative 1. Let's plug in 3. 3 squared minus 6 times 3 plus 7. 3 squared is 9. 9 minus 18 is negative 9. Negative 9 plus 7 is negative 2. And I'm going to plug in another one. I'm going to plug in 4. 4 squared minus 6 times 4 plus 7. That's 16. Minus 24 is negative 8. Plus 7 is negative 1. Okay. And once I get a y value that is repeated, as such as these negative 1s, I know that I have found my vertex. I have found the middle of the parabola. So let's plot these points and you'll be able to see what I mean. So 0, 7 is right there. It's got an open circle because x does not include 0 for our orange line here. Then I've got a 1, 2, a 2, negative 1, a 3, negative 2, and a 4, negative 1. So let me zoom in on this real quick. What you're seeing here is the beginning of the parabola. You're seeing the vertex and 2 points on either side of the vertex. So here's our vertex at the bottom, and we have this scoop on the bottom here, this bowl, and knowing what we know about quadratic functions and their shape, we know that it has to be symmetrical around this point. So now I can see that I have another point right here to match this 1, 2, and I also have another point right here to match 0, 7. And now I can connect them, right? I also could have found those 2 points by plugging them in the way that we did with these. But once you have, again, once you have those repeated y values, I saw this negative 1 and this negative 1, that indicates that we have both sides of the parabola, and I can find the rest of it. Okay. So there's our graph. And let's talk about our domain and range now. Our domain asks, are there any numbers that we are not allowed to plug in to this equation? Are there any x values that are not included on the graph? And the answer here is no, because this arrow goes off to negative infinity, and there are no x values that are not covered. If we didn't have these, if we didn't have this solid dot, perhaps x equals 0 would not be included if both of these were open, for example, but that does not happen here. So our domain is all real numbers. And then our range asks the same thing. Are there any y values that are not part of this function? And the answer is no, because this goes down to negative infinity. The green line goes down to negative infinity. And our y values are all the way up to here where the orange line picks up. We've got some overlap here, and then this goes off to positive infinity. So when we're looking for all of the y values, we also have all real numbers. Right? That's not always going to be the case, but it is for this particular example. let's take a look at one more. And then there will be a couple for you to do on your own. Number 11. Okay, so for the linear equation, I am going to do it in pencil and then erase the section that doesn't count again. So negative 2x minus 1 means I've got a y-intercept at negative 1 and then a slope of negative 2. So I'm going to count down 2 and to the right 1. Use a straight edge after I get a couple of points. And too much stuff is in the way. There's my line. And now I'm looking at this. Well, x has to be less than or equal to 0. So everything where x is greater than 0 doesn't count. So let's make the linear one green again. So x is less than or equal to 0. I'm going to include a solid dot because of the or equal to bar here. And my pencil line didn't actually hit the right spots, so I'm going to redraw it and then erase it. Right. If you are more careful with your pencil line, that won't be an issue for you. Right. So there's our first section. And the next section, let's do this one in purple. We've got 3 to the power of x minus 9. Well, I think, again, the easiest way to do most of these is going to be to plug in some numbers. So let's start with 0. Again, we're looking at numbers inside this domain. And then do a couple more. 1, 2, 3. Probably won't need more than that. So 3 to the power of 0 minus 9. Oh, we got to review some rules of exponents. Anything to the power of 0 is always 1. So 3 to the power of 0 is equal to 1. 1 minus 9 is negative 8. Okay. Then 1, 3 to the 1 minus 9. 3 to the 1 is 3. 3 minus 9 is negative 6. Then we've got 3 squared minus 9. 3 squared is 9. 9 minus 9 is 0. And then 3 to the third minus 9. 3 to the third is 27. 27 minus 9 is 18. And that is already going to be off of our graph, so that's enough. Just in case this comes up, another exponent rule that you might need is the negative exponent rule. The negative exponent rule is x to the negative a is 1 over x to the a. So if we were going to graph this function to the left, we would end up with smaller and smaller numbers for this 3 to the x, right? This would be smaller and smaller and closer to 0. It would be 1 over 3 squared, and then 1 over 3 to the third, and then 1 over 3 to the fourth, and it would get closer and closer to 0. That's why we end up with that asymptote that goes to the left on the exponential functions. Okay, let's graph these. 0, negative 8. It's got an open circle. Need an open circle there because this part of our domain does not include this purple line. Then we've got 1, negative 6. We've got 2, 0. And 3, 18 is going to be way up there somewhere. Okay. So I'm going to draw this line, and when I draw the rest of this line after this x-intercept, I need to make sure I don't hit the next vertical line, because 3, 18 is the next one. So I even kind of messed up with my purple pen, but you see what I mean. It needs to be very close to vertical. It cannot go off this direction. It cannot cross any of these lines, because x equals 3 means y equals 18 all the way up here. It's got to aim for that point up there. Okay, and now our domain. Our domain includes all real numbers, right? X values, we can plug in any X value, negative, 0, positive, whatever, irrational, etc. Our range, though, is not all real numbers. We do not have any part of this function on either of these lines that is less than -8. Nothing exists down here, right? So y must be greater than this point here, which is at -8. So our range is limited. It only exists above this line. Okay. All right. So go ahead and give number 10 and 12 a chance on your own. And when you're ready, come back to the video and we'll talk about writing piecewise functions. So, writing piecewise functions. We need to identify which section of the graph these are in. So it looks like for number 13, we're separating the two pieces at -2. So one of them is x is less than or equal to -2. That's this line here. And the other one is x is greater than -2. That's the exponential. So our function starts with f of x equals something when x is less than -2. That'll be the equation of this line. And something else when x is greater than -2. That'll be the equation of this line. Okay. So what are those equations? Well, there's a couple ways you can do this. When you're thinking of linear equations, you can identify the slope and the y-intercept and write our equation as mx plus b. Or you can identify the slope and another point and plug it into y minus y1 equals m times x minus x1, and then solve into mx plus b. And this is exactly what we were doing in those handful of examples, or handful of, there we go, these earlier things. This will help a lot. The 1C, writing equations. We reviewed how do you write linear equations? How do you write quadratic equations when you have the roots or when you have the vertex? And how do you write exponential equations? So 1C will help a lot with this. So let's go back. Where are we going? There we go. Okay. So in this example, if you were to continue this line on the graph, we can identify where the y-intercept would be if it existed. And it looks like it would be down here at 3. Okay. So it's going to be something x plus 3. And then we need to identify the slope, and we can identify the slope between any 2 points. It does not matter. We're counting down or up first and then to the right. So in this example, if we count down 3, and then we count to the right 3, that's going to be a -3/3 slope, which is the same thing as -1. So there's our equation, -x plus 3. And then for our exponential, couple ways, well, probably only one way to find an equation of an exponential. You're looking for, I'll just put our little review right here, a times b to the power of x. A is the y-intercept, b is the common ratio. So in this example, a is very clear, it's right there at 4. So this is 4 times something to the power of x. And the common ratio is that number that we're multiplying one y value to get to the next y value. It's this number. So let's create a table, plug a couple of these points in, and then figure that out. So we've got x equals 0, y equals 4. When x is 1, y is 2. When x is 2, y is 1. And that's enough. We don't need a ton. The 3 points that I just put in that table are these 3. So what number do we multiply to turn 4 into 2 and turn 2 into 1? Well, it's divided by 2, but we cannot write our equation with division. It has to be done with multiplication. So divided by 2 is the same thing as times 1/2. So our equation is 4 times 1/2 to the power of x. Okay. And number 14 I'm not going to do for you. You get to figure that one out. This one is exponential. This one is quadratic, so you'll have to go back to 1C and review how do you write a quadratic equation from a graph. And when you're done with that, you can come back up and check your work in this binder. All the answers will be available for you. And thank you so much for hanging with me for a whole 20 minutes. I appreciate it.